Hey guys, I'm sorry I can't be there today. I'm a little under the weather, and you'll be seeing me on Monday of next week. So in the meantime, um, this week we're going to focus on some fundamentals. Think about calculus. This is where you are, right? In order to be successful in calculus, we need to make sure that the algebra skills and the trig skills are there so that we can be successful. Because you may understand everything that's going on in calculus, you may understand the concepts, I'm sure you will, but you won't be able to answer those questions and like get the final correct answer unless you have the good algebra and trig skills. So a little bit of housekeeping. You were supposed to have a quiz today. That quiz, that quiz we will move to Monday. So the Monday I'll see you, which is next week, next Monday, right? That'll be when your quiz is, and that I'll take exercise 7.3 that day as well. Okay. Um, this week we're focusing on foundations. So specifically today, factoring. Okay. So I'm going to give you some delta math to do to work on your factoring. Um, just big picture, what is factoring? So you're probably used to factoring being seeing this x squared plus 5x plus 6, and then you do the x, you want two numbers that multiply to 6, add to 5, and those are 2 and 3, so we get our factors x plus 3 and x plus 2. And this is factoring. Factoring is just going from, so this is right here, this is factors. It's separating a expression into two smaller expressions that multiply to get the larger one, right? So x plus 3 times x plus 2 gets me x squared plus 5x plus 6. And you're asked to do this a lot in calculus, specifically at the beginning in our next kind of section, which is we're going to be exploring limits. And you know how finding the holes and finding the vertical asymptotes, you need to factor the top and bottom of the rational expression. That I think is, based on what I'm seeing, that's challenging for people, and so we need some practice in factoring. So this is very basic factoring, right? This is what we learned. You learned this with Mr. Oline, Math 2. But some other kinds of factoring which are really important. One that I've been introducing to students, some students know it already, but it's just taking out the greatest common factor. So for example, if we have 3x squared plus 9, notice that in this expression, the 3 and the 9 are both divisible by 3. You see that? I can put 3 into both. What you can do is just take the 3 out of the expression, and then you say, okay, 3 times what is 3x squared? That's just x squared. 3 times what is 9? 3. And you can see that 3 times x squared is 3x squared, and 3 times 3 is 9. Okay? That's taking out the greatest common factor. So I'm going to have you practice that. You can also do that with variables. So variables, for example, let's say we had 3xy squared plus 2xy. Now notice here that the 3 and the 2, they do not share a common factor, so I can't take out any integers, any numbers, right? But notice how both expressions, I have an x here, an x here, I have a y squared here, and a y here. So what I can take out is variables. I can take out x, y, 3y plus 2. You can see, and you can always test your answer by multiplying it back. xy times 3y is 3xy squared, and xy times 2 is 2xy. So that's number 2. That's taking out the greatest common variable, if you like. It's the greatest common factor as well, but it's variables instead of numbers. What else do we have? Okay, so back to trinomials. So when I say trinomials, I'm talking about these. X squared plus 5x plus 6. These are trinomials because so it tries three terms. Okay. Um, these you know how to do. Now, you can only do this x method, the 6 and 5 x method, when um, this value right here is a 1. So you notice how, let me undo that, so ugly that does not look like a 1. When this is a 1, you can do this method. If this is any other number, if this was like a 2, x squared plus 5x, you cannot do this. You cannot do the whole x method thing, okay? So that's what we need to practice because there's an expectation on the problems that you're seeing that you know how to solve those kinds of problems where that is not, where that's not one. So let me show you a couple examples. Number one, something you'll see maybe something like this, 3x squared plus 15x plus 18. Now, whenever you come across a trinomial or an expression in general, you're going to want to take out the greatest common factor if possible. So just like I showed you those two prior examples, taking out the 3 and the xy, you want to look at this and say, oh, can I take anything out of this? And the answer is, in this case, yeah, I can take out, see, 3, 15, and 18 are all divisible by 3. I noticed that. So what I can do is take the 3 out, and then you have x squared plus 5x plus 6. Notice 3 times x squared is 3x squared, 3 times 5x is 15x, 3 times 6 is 18. And then what you're going to do is then factor this again. Right? You got to factor it again. And we already did that. That was the first one I did. So that's just 3x plus 2 x plus 3. Okay? So that's like the ideal. This is like ideal. This is like, oh, this is nice. You know, like this is kind of best case scenario. It won't always be like this pretty. And then you'll get other situations where you can do that. So let me write one out. Let's say we have, let me change the color back to this, 3x squared 17x 24. Yes. Okay. So in this case, look at this problem, right? I cannot take anything out. Look, the 3, the 17, the 24, there's no common factors here, right? These do not align. Yeah, 24 and 3 are both divisible by 3, but the 17 is not. So I don't know. I'm not sure how they're going to teach you this in the Delta. They might have their own method of teaching you, but I will teach you the way that I know, the way that I do this, and the way that I learned how to do it. So I guess number one is looking at this. Um, I can sort of set up my factors, even though I don't know exactly. Um, I don't know all the factors yet, but I do know some things for sure. So if we look at, let's look at this first number right here. So with the 3 right here, there's only one way to get 3, and that because it's a prime number, right? I know for sure I'm gonna have to have 3x plus something, some number, times x plus some number. Like, I know this because x times 3x is 3x squared. That's the only way I'm going to get 3x squared. And I know it's going to be plus and plus because, change to green. Because see, because this is a plus and this is a plus, that means I must have plus and plus here. And these also must be plus and plus. Okay. Um, so how do I find, so what's missing is just these last two, these last two values here. What's going to go there? To find that, this is what I do. So I'll draw the window back from the window method. and I'm going to reverse, kind of go in reverse. So I know that this is 3x. I know that this is x. That's the only way I'm going to get 3x squared. See that? It's the only way. No other combination will work. So that's for sure. Then that's how I get my 3x and x over there. And then I also know that I need two numbers that are going to multiply to get 24. Okay, so these values here and here are both going to be factors of 24. But the condition is that my values, adding a lot of color to this right now, my values here and here need to add up to equal to 17. Okay, that's the one condition. So like, I can't necessarily do like 1 and 24 because that's not going to add up to equal 17. You see what I'm saying? So what you kind of have to do is you look at the factors of 24, you test them, and then you are also going to have to consider that you're multiplying one of those factors by 3 when it goes in. Okay. So if you think about 24, factors of 24, I got 1 and 24, I've got 2 and 12, and I've got 6 and 4, and I've got 8 and 3. I'm going to write these right now. So we have 124 is not going to work. Straight up not going to work. There's no way I can get 17. 2 and 12, well, 2 times 3 is 6. 6 plus 12 is 18. That's not going to work. 8 and 3, well, 3 times 3 is 9, plus the 8 is 17. So this one is going to work. And I'll show you why, in case that's confusing. So in this problem, I said that 3 times 3 is 9. So if I put a plus 3 right here in this box, now it'll be 3x times 3 is 9x. See that? And then in top one, I'll put the 8 here. 8 times x is 8x. And so now you can see that this 9x plus this 8x gets me the 17x. That's good, that's what I want. And the 8 times the 3 is the 24, and the 3x times the x is 3x squared. And now I'm just going to fill in my factors, 3x plus 8 and x plus 3. And so final answer is these two right here. I hope that made sense. I am sick, so that's my excuse if that was very unclear, and Delta may explain it better than me. But I hope that kind of got you started. Anyway, good luck on the assignment today. I expect that to be done. I'll have a look at how you guys are doing. Do the Delta math. You guys got to do it. You guys got this. And I'll see you soon. Thank you.